The materials. First is one piece of a balloon. Second is one piece of empty bottle. Third is a funnel. Gloves to protect our hands for unnecessary chemicals. Fifth is mask to protect our nose and mouth for unnecessary chemicals. Sixth is lab gown to protect our body from unnecessary chemicals. Seventh is cup of vinegar, and last is cup of baking soda. Objective. First is to better understand the concept of Dalton law of pressure. Second is to determine the individual pressure of each individual gases. Third is to prove the total pressure of a gas is the sum of the partial pressure of each individual gases. The procedures. First, prepare all the materials. Second, get the bottle and fill it with less than vinegar. Third, with the use of funnel, fill the balloon with baking soda. Fourth, put the balloon filled with baking soda on the top of the bottle with vinegar. And lastly, shake the bottle to mix it up. Wait until the balloon expands. In conclusion, when vinegar and baking soda are mixed together, it creates a carbon dioxide gas and form a bubbles. The reaction of two ingredients was quickly visible after they mixed together. In addition, the pressure of carbon dioxide dropped in the balloon as soon as the balloon is placed on the top of the bottle, letting us know the amount of the pressure by the size of the balloon.
Hello, today we are going to make an experiment, and these are the materials. And let's go! For the first material, these are the 2 pieces of balloon. Provide also 2 pieces of empty bottles. And we will also use a funnel. We will use gloves to protect our hands from chemicals. Face mask to prevent us from smelling unnecessary smells from chemicals. And we should also provide a lab gown. We have here the hydrogen peroxide and bleach as a primary materials for this experiment. Vinegar and baking soda is also our primary materials. And that's all the materials that we will need. We have 3 objectives for this first experiment. The first one is to better understand the concept of Dalton's law. to determine the individual pressure of each gases and to prove that the total pressure of a gas is the sum of the partial pressures of individual gases. After we get all the needed materials, we will get two bottles and fill the other bottle with an ample amount of bleach. While pouring the bleach in the bottle, we will use a funnel to avoid spilling the bleach on the table. After pouring the bleach in the bottle, we will fill the balloon with a hydrogen peroxide. Again, we will use a funnel to properly pour the hydrogen peroxide inside the balloon. We will now place the balloon at the top of the bottle by opening the mouth of it widely but carefully. After that, we will now pour the hydrogen peroxide inside the bottle. We need to shake the bottle to mix up the chemicals in it. And this is the result of the mixture of hydrogen peroxide and bleach. In conclusion to that, when hydrogen peroxide and bleach are mixed together, it will create an oxygen gas and it will form a bubbles. In order to make this experiment possible, the bleach must contain sodium hypochlorite. As soon as the two ingredients are mixed together, the reaction quickly occurs and the amount of pressure of gas was visible in the size of the balloon. For this part, we need to grab a new bottle and fill it with vinegar and baking soda. We will use a funnel again to avoid spilling the materials on the table. We will now take out the balloon from the bottle of hydrogen peroxide and bleach mixture. We will now fill the bottle with baking soda. Then carefully put the balloon at the top of the bottle and shake the bottle to mix it up until the balloon expands. This will be the result of total pressure of oxygen gas and carbon dioxide. In conclusion, this experiment proves that when you add the partial pressures of different mixtures, example given, oxygen gas and carbon dioxide, the result would be the total pressure of the two mixtures. In the last experiment, you would notice that the last balloon was bigger than the first one because it is the total pressure of oxygen gas and carbon dioxide.